Okay, so now we come to chapter 3 on research design. I mentioned this, remember, as part of your research plan. This is a really crucial part. So this to me is a really very important part of this course. Many of these issues are not covered in a standard statistics course. Some of them are, but some of them are not. And so these are things we need to understand very well in order to create good research designs. So our learning objectives are to understand representativeness, probability sampling, and non-sampling error. So these three are all really important. Probability sampling is often taught in statistics courses, but the other two are not always taught. So we need to start by defining what is a population. So a population is simply the potential respondents of interest. So it could, for example, be adults aged 18 or above resident in Hong Kong, if we're studying people in Hong Kong. That sounds very simple, but we have to be a little bit careful. What exactly do we mean by resident in Hong Kong? Right? How long do you need to have stayed here in order to be considered a resident? So in fact, that's quite tricky. In fact, the government changed the population definition about 10 years ago. Actually, more than 10 years ago now, nearly 20 years ago. Right, so the government changed the population definition, so it now references normally resident in Hong Kong. So it turns out that essentially it means that out of the previous 12 months, you were here 6 months at a time. But even that can be a little bit tricky. So what do we mean by present in Hong Kong? So consider two tricky cases. What if I have a flat in Shenzhen and I come to work in Hong Kong every day? Am I resident in Hong Kong or am I resident in Shenzhen? Okay. What if I live in Hong Kong and I go to work in Shenzhen every day? Am I resident in Hong Kong or am I resident in Shenzhen? Okay, now let's try a third possibility. I live in Hong Kong and I work in Shenzhen, but I work nights. So that means I spend every night in Shenzhen and every day in Hong Kong. So you can see it's not always that clear what resident means. Now, of course, those are very special cases. It's not going to apply to most people, but it makes it clear it's not always quite as obvious it may appear what resident means. But it doesn't have to be about human beings. It could be air temperatures at the Hong Kong Observatory. Right, so that could be our population. So that's still rather vague, right? How often are we measuring the temperature? What time of day do we measure it? Right? So those are all issues that we would need to sort out if we're talking about air temperatures at the Hong Kong Observatory. Okay, so having got our population defined, what is our sample? So the sample is simply the respondents we select from the population for study. So again, this seems like very straightforward, but it's not always quite that simple. So for example, if I say I've drawn a sample of 500 mobile phone users in Hong Kong, selected randomly using their phone number. Okay? Any problems with that? Well, even there, it's a little tricky. Do we mean, are we including tourists? Do we include somebody who's come into Hong Kong and has a roaming connection to Hong Kong for one day? You might say, well, no, because they don't actually have a Hong Kong number. Right? So if we sampled using a Hong Kong number, we wouldn't get them. Well, what if somebody comes into Hong Kong for 2 days and they buy a SIM card to use while they're in Hong Kong? Do we want to include them? What about a young child who has their own mobile phone? Do we want to include them? And then what about somebody who perhaps has 10 different SIM cards, which they use 9 for work and 1 for their personal use? Right? That means they would have 10 times the chance of being selected as somebody who only has one number. Right? So all these things become a little bit more tricky when we come down to the details of selecting the sample. Okay, let's look at another example. So let's say we're looking at air quality and we have 1,000 average daily ozone levels recorded sequentially at the street level monitoring station in Causeway Bay. Okay, any problem with that? Well, actually there are at least two problems. What happens if there's a typhoon and a monitoring station breaks down? What are we going to do about those missing data? Well, the other issue is, does it matter when in the year we start? So for example, if we start in the winter, when the air quality is generally worse, and we collect 1,000 daily ozone levels, we don't get equal numbers of measurements for each season. But we know that the air quality varies across the seasons. So actually 1,000 is not a very good choice. We probably should be choosing some multiple of 365, so it's a particular number of years, so our sample is balanced across all the different months of the year. Okay, so those are things we would need to take into account when we're drawing our sample. Okay, and then units of analysis. What's a unit of analysis? A unit of analysis are usually the things we're sampling. So if it's adults aged 18 or above, it's people. Right? If it's air temperatures, it's a particular measurement of air temperature. But it could be a household, right? So even if we're collecting people, if we use fixed line telephone numbers are linked to a household, not a person. So if we're really interested in people, then we also have to select people from within the households. Right? But it doesn't have to be human being linked. Again, it could be rats, it could be words, it could be songs, it could be any countable object. And also we may have more than one possible unit of analysis. So for example, if we sample students in schools, it could be we want to analyze the students level to understand how students vary. It could be the class, that we want to understand how different classes and different schools vary. Or it could be the school level. So we might have multiple levels at which we might analyze the data, which may be different from the level that we have sampled it. Okay, so now we come to a core concept, representativeness. So what's representativeness? So the idea here is, when we draw a sample, we don't usually want to draw conclusions just about that sample. We want to try and draw conclusions about the whole population. So if we want to draw a conclusion about the population, that means we are assuming implicitly that the sample is like the population. Right? So representativeness is telling us to what extent is the sample similar to the population, not necessarily on all characteristics, but at least on the characteristics of interest for our research. Right? So remember our explanatory variables. We at least want that our explanatory variables should be similar for the sample and the population. Right? That's essential if we want to draw conclusions about the population based on a sample. So that of course begs the question, how can we ensure representativeness? So in general, that's extremely hard unless we use either probability samples, which we're going to talk about in a minute, or collect data on the whole population. So why don't we just collect data on the whole population? Well, usually we don't do that because it's too expensive. So in fact, in Hong Kong, every 10 years, the government does what they call a census. A census in theory means collect the data on the whole population. But if you look at the census data carefully, you discover that in fact, even the government, who has lots of resources, when it comes to the census, they collect very little information on the whole population. Most of the information they collect is from a sample. So when they do the census, only 1/10 of the population answers the full questionnaire. 9/10 are just asked the basic information about their household. Right, so we collect very little information on the 9/10 just to make sure we've got the population numbers right by age and gender. The detailed information is only collected on a sample because it's simply too expensive to collect all of that information, and actually arguably we don't really need to collect such a big sample. Why not? Well, we're going to talk about that later. So what is a probability sample? A probability sample is a sample where all sampling units have a known non-zero probability of selection. So probability just means chance. We're going to talk about probability in more detail later. So we're saying all the sampling units should have a known chance of selection which is not zero. So why do we need those two things? Well, first of all, it must be non-zero because if some sampling units have a zero chance of selection, then our sample cannot be representative because there's people who are excluded. Known because if the chances are not equal, I need to take that into account. So for example, I said before we might sample households and then sample people within households. So why does that matter? Because if I say that each household has an equal chance of selection, and then I choose one person randomly in each household, that means if I live in a one-person household, I'm guaranteed to be selected at the second stage. If I live in a 10-person household, I only have a 1/10 chance of selection at the second stage. So if you put the two pieces together, unless you make some adjustment, it would mean people living in big households have a lower chance of selection than people in small households. And in Hong Kong, small households are quite often elderly people living on their own. So we would overrepresent elderly people and underrepresent young people, particularly children, if we sampled in that way without making any adjustment. So if we know the chance of selection, we can make an adjustment for the fact that the chances are not equal. So probability samples are an implicit requirement for all the hypothesis testing and statistical models we're going to use later on. Now there's several different ways to draw a probability sample, so we're going to start with the simplest form of all. So the simplest form of probability sample is what we call a simple random sample. So a simple random sample means that all combinations of sampling units with the specified sample size have an equal chance of selection. That in turn also means that all sampling units must have an equal chance of selection. So if I had a class of 10 students and I draw a simple random sample of size 2, that means I have 10 possible students to choose as the first one. There are 9 students left for me to select as the second one. So that's 90 different combinations, but I don't care which order they were selected in, so there are actually 45 different possible pairs of students in my class of 10 students. So there are 45 possible pairs, all of which are equally likely to be selected if I have a simple random sample. Okay, so that's relatively straightforward to do, can be done, at least if I have a list that I can draw from of all the students. Right, so we'll see that simple random samples are not always practicable, but at least the statistical analysis is the simplest if I have a simple random sample. So sometimes simple random samples are not very practicable. So a good example of that is if I wanted to sample school students in Hong Kong. So let's say I want a sample of 500 secondary students. So how would I draw that? Well, you might say, well, if I start with a list of all the secondary students, it's still very straightforward, but there is no list which I can obtain. So usually what we do is what we call cluster sampling. This means we sample at 2 or more levels. So we could sample at 3 levels, for example: the school, the class, and the student. So we can easily get a list of all secondary schools. So first of all, I should say that almost no students in Hong Kong are taught at home. So nearly all secondary school students are in the schools. So we can at least say that we're going to exclude the ones who aren't in school, or we could separately sample from those who are being homeschooled. But it turns out we can obtain a list of all the secondary schools. So if you go to the government website, you can download a list of all the secondary schools with their addresses. So we could easily draw a sample of schools. Right? So once you've got a list of schools, you've got your sample. Now the tricky part, of course, is actually to get consent from the schools, because that generally means you at least need to get the principal to agree. And frankly, many principals are reluctant to agree. Even when we've done surveys on behalf of the government for the Department of Health, it's sometimes very hard to get principals to consent. They're very busy, they don't want to deal with a survey. Now let's ignore that part for the moment. Let's assume we've been able to draw the sample of schools. If the school agrees to participate, they will normally happily tell you how many classes they have. So you could draw a sample of classes within the school, and then the school should be able to help you draw students within the class. In practice, we quite often sample all the students within a class, because if they've agreed for you to go and disturb a class, it may be easier just to collect data from all the students in that class once you've got that consent. So this actually, in that sense, is much more convenient from the point of view of the researcher, because you don't have to deal with so many schools, you don't have to deal with so many classes in order to get your sample size. So what's the problem? Well, there is a disadvantage. Students in the same class are likely to be more similar than students drawn at random. So why might that be? Well, first of all, a school has a philosophy. So if the students are in the same school, they're being taught using the same philosophy. The schools usually are recruiting a particular target, maybe a particular district, maybe a particular income or ability group. The teachers are common within that school. And of course, within a class, you have social interaction. Right? If you go to school with someone in the same class for 7 years, naturally you share a lot of common experiences, and you become more and more similar in your outlook across your time. So what can we do about this? Well, we can actually measure something called intra-cluster correlation, which measures how similar the students are within the same cluster, the same class in this case. And we can use that to adjust the sample size. So the effective sample size is smaller than a simple random sample of the same sample size. But even so, this is still usually a much more efficient way of drawing a sample of secondary students than simply drawing a random sample. It also has the other advantage that we often do want to also analyze at the class level and the school level to understand whether the differences we measure are due to socialization in class or due to the school philosophy, rather than just understanding variation from across students. Another strategy we can use is something called stratified sampling. So stratified sampling means we sample within subgroups of known size that are relatively homogeneous. What does homogeneous mean? Homogeneous means similar. So we can actually make similarity a good idea if we know the size of the subgroup. So what would that mean in this case? Well, for example, we know one key thing is that students within school are developing, and one key proxy for development is age. Or even if we can't do age directly, year group is usually in most cases very closely associated with age. So students within the same year group are likely to be quite similar, and we can usually know how many students there should be in each age group or each year group. And we can take account of this. So when we're drawing the sample of classes in the school, it's very unlikely that we would just draw a random set of classes. We usually would choose the classes to be representative across the different year groups. So if, for example, it was a secondary school running from secondary 1 to secondary 7, and we wanted to draw 7 classes, then we would often draw 1 from each year level. Right? There are something like that. So that sort of stratified sampling actually gives more precise results than a simple random sample, because it ensures that our sample is representative across year group, whereas a simple random sample might just by chance have more students in some year groups than others. Systematic sample. So systematic sample actually is a way of drawing a random sample. So if we have a list for our whole population, an ordered list, then a systematic sample involves selecting a random start point and then selecting every kth individual, where k is the ratio of the population size to the sample size. So this works very well in some situations if the list order is associated with an important variable, but it works very poorly if there are periodic patterns in the list. So what do I mean by that? Well, for example, let's say I was drawing a sample from this class and I based it on the class list. So why might I not want to draw a sample from the class list? Well, the reason is because your order in the class list is probably associated with which place you come from. Right? So if your surname starts with Z, it's quite likely you're from the mainland. Or Q, come to that. Q and Z are not very common starting initials for surnames outside of mainland China. So actually, your order in the class list has something to do with where you come from. Right? So this might introduce some bias in my sample if I just used the class list in the original order. So if, on the other hand, I knew your scores on some test before you came into my class, I might want to draw a sample that was representative according to your ability level. So I might sort you by your performance on that test. So in that situation, putting you in the order of your performance would be a good idea. It would help make sure that I'm representative across the different ability levels. Or lastly, if I have no idea and I just want to protect myself against any periodic pattern, I could randomize the order in the list first before I draw the sample. So then it's just a way of drawing a simple random sample. Okay? Now, there are other ways still to draw samples. So for example, there's what we call a network sample. So I didn't used to teach network samples because I decided it was too hard to explain. But assuming you belong to some social media network, then actually it's a very simple concept. So the idea of network sampling is a sampling strategy that draws a sample through a random selection of links in a network. So that sounds rather vague and abstract. So let's try and be more specific. So it assumes that the network is all connected up. Okay, that's the key underlying assumption, which may not always be valid. But the idea is sometimes a simple random sample is not possible. So this is a way of trying to draw a sample, particularly of very special groups, where they're connected up in some way. So this is important because a network sample yields representative samples of difficult to sample populations if the assumptions are valid. So let's have a think about an example. Let's say This says I want to sample drug addicts. So that's maybe too extreme. Let's just say I want to sample people who've ever used marijuana. So the problem is marijuana is illegal in Hong Kong. So it's very hard to ask people over the phone, have you ever taken marijuana? They may not want to answer me because they're worried they're admitting to a criminal act. So how might I do it? Well, with something like drugs, usually you have a supply network. So of course, it's possible you're growing your own marijuana, in which case you may not need to have a supply network. But for most drugs, you're getting it from somebody and they get it from somebody else. So people are usually connected up. So one of the problems that if I don't have some form of network sampling is I would rely on the people I can easily contact. So such as people who have already been arrested for a drug offense, and I start from them. So the problem is that these are people who got caught, who may be very different from people who don't get caught. So if I ask those people, who do you know who takes drugs or who has ever given you drugs, then they're part of your network. And if we go several links down the network, so I don't use the person I start with, but 2 or 3 links down the chain. So let's think about it in terms of Facebook. So let's say if I knew you all belong to Facebook. So instead of sampling all of you, because I want a sample of young people, I ask you to give me a randomly selected one of your Facebook friends. And then I don't collect data from your random friend. I ask that random friend for one of their random friends. And at each stage, the only requirement is they must be in the right age group. So if everybody is connected up, which we can assume as the first approximation, then by going several links down this network, I end up with a sample that is very close to representative of the whole population. So this is a much better alternative to draw a sample in these situations where it's very hard to contact people. Okay. Now there's also geographical samples. So for example, distance sampling. So distance sampling, the idea would be you start out with a map. You either randomly put points on a map or lines on a map, and then you measure distances to objects. So for example, in the past I have done counts of how many people are marching along Hennessy Road. So the way we usually would handle that is count the number of people going under a bridge in a random sample of time periods. So if we draw a random sample or a systematic sample of time periods, and then within each time period we capture video and count how many people go under the bridge, right? So that would be an example of using a geographical method to help us draw a sample. Or if we wanted to estimate the number of people in Victoria Park, we could draw a random sample of areas in Victoria Park, and then in those small areas count how many people there are. So again, if our small areas have been drawn randomly, this should give us a representative sample. Okay? Now, in the rest of this course, we're going to assume simple random sampling for simplicity. There is one other issue we haven't talked about yet, which is where is the sample size relative to the population size. So we're going to talk about that later on. Now, one other very important thing, though, is to distinguish between sampling errors and non-sampling errors. So sampling errors are just about the fact that we've used a sample rather than the whole population. So clearly, if I draw a big enough sample, the sampling error becomes very small. So in the extreme case, if I sample the whole population, the sampling error is 0. Right? There is no error due to drawing a sample. The problem is that's not the whole story. Anyway, let's think about the sampling error first. So if we have done a probability sample, it turns out that the sampling errors can be quantified in a probabilistic way, which we will see later on. We can show that if we know the sample design and the sample size, we can estimate the sampling error. So the sampling accuracy increase is proportional, it turns out, to the square root of the sample size. Or if you want it the other way around, the sampling error decreases proportional to the inverse of the square root of the sample size. So in other words, we can know in advance how big the sampling error is likely to be for different choices of sample size. And because it relates to the square root of the sample size, the benefit for making the sample size bigger gets less and less as the sample size gets bigger. So that's why we often will not choose a very large sample size, because the sampling error is no longer decreasing very much. So what we have to worry about then, in the sampling error, as I said, is relatively straightforward. We should be able to calculate the sampling error as long as we use a probability sample. But non-sampling errors are the bits that are much more worrying. These are the things which are not due to drawing the sample, but all the other reasons why the data we collect may not be the correct data. So what are those? Well, one is non-contact. So we contact either a person or an object or something else, and we're unable to find that item. So perhaps we were trying to sample animals and the animal ran away. Or we're trying to sample human beings at home and they're never home. So that's one of the reasons for a non-sampling error. It could even be, if it's a human being, they refuse to participate when we contact them. Or it could be they didn't understand the question, so a misunderstanding. It could be that they don't want to answer the question. So I mentioned before, if I'm asking you, have you ever smoked marijuana? You may lie to me because you're worried that you can't trust me, that I might report you to the authorities. Or it could be a mistake, right? That mistake could be that they just simply, by mistake, answered the wrong code. Or a coding error means that the person who's inputting the data writes it down wrong. So these are all reasons why the data may be incorrect. Now, increasing the sample size, we've already said, reduces the sampling error, but generally the cost will go up. Usually the cost goes up at least proportional to the sample size, even though the accuracy only goes up proportional to the square root of the sample size. So the benefit of bigger and bigger samples gets less and less relative to the sampling error. However, we need to recognize increasing the sample size generally will never decrease non-sampling error. In fact, it may even increase sampling error. Why? So for example, if I'm doing a survey and I need to hire interviewers to collect the data, the more interviewers I hire, the harder it is for me to ensure quality. I have to hire more supervisors. I can't be as selective in choosing the very best interviewers and the very best supervisors. So it gets harder and harder to ensure quality as the sample size increases. So it's essential that when you're choosing a research design, you not only think about sampling errors, but you also think about non-sampling errors, because non-sampling errors are hard to quantify or take into account. So even including everybody in the population, non-sampling errors will not go away. Now sometimes we can get some idea of the problem. So for example, let's say non-response bias. So how might we get some attempt on this? Well, for example, if we keep a record of how many times we try to contact someone. So let's say we're doing a telephone survey. Some people on our first attempt at calling their number, they answer the phone and agree to participate. Other people might take 2, 3, 4 or 5 calls before we finally get hold of them and they agree to participate. So if there is some bias with non-contact, we would assume that the responses should be different depending on how easy it was to contact that person. So amongst the ones we've ever contacted, can we see a difference depending on the ease of contact? right? So that's one way we could at least get some idea of how serious the problem is. Because for some topics, it may make very little difference, right? But for some topics, we may find very big differences depending on how easy it was or how hard it was to contact people. So this is not just a problem with social research. We need to be aware of non-sampling error for other forms of information. So for example, if in a laboratory you fail to calibrate your equipment before you use it, that's a non-sampling error, right? Collecting more data will not make that bias go away. It will affect all the observations on that time when you use the equipment, right? So the more measurements you take does not reduce bias due to non-sampling errors. Or similarly, if you use equipment that is not suitable for that proposed measurement purpose, you can't fix this using the statistical analysis, right? It means your data will simply be wrong. So I've got a few examples here. These are about surveys because that's one of my interests. So for example, a telephone survey in Hong Kong, we used to have printed telephone directories, and Hong Kong used to have a Chinese directory and an English directory. So many of my fellow researchers would only ever use the Chinese telephone directory, and I tried to persuade them that was a very bad idea. So do you have any idea why? So if you've got an English directory and a Chinese directory, why might it be better in Hong Kong, which is generally Chinese speaking, to use the English directory? Can anybody guess why? Well, it turned out that the coverage of the English directory was higher than the Chinese directory. In fact, actually the best thing is to combine the two together. So you get even higher coverage if you had a complete coverage of everything in the English and the Chinese directory. But it sort of begs the question, why would you find more people in the English directory than the Chinese directory? So I used to know somebody who worked for the telephone company, and he explained to me the cultural and economic reason why this happened. So it turned out, if you did not want to be in the telephone directory in Hong Kong, you had to pay money to the telephone company. However, you could choose to be in the English directory only, or the Chinese directory only, or both. That was your choice, but you couldn't choose to be in neither directory without paying money. So you think about it. If you're smart about money and you don't want to be found easily, which are you going to choose? Right? Of course, the English directory, because if my name is John Wong, there might be 50 John Wongs. And if all you know is my name is John Wong, it's going to be hard to find me. But if you know the 3 characters of my Chinese name, in most cases, there will only be a very small number of people with the same 3 characters. Right? So that was a way that people chose to be less visible without paying money. So that then makes a problem, right? If you have a bias in your selection process, clearly this is going to bias your results. So it means people, if you only choose the people from the Chinese directory, then people who are careful with their money and don't want to be found will generally not be in your sample. Okay, so another very good example, I mentioned about contact attempts. So for example, if you only make one contact attempt on each telephone number before you move on to the next one, there will be a very strong non-contact bias. So how does that affect things? Well, for example, poor households or single working households, they're often out to work, or young households without children who are often out at work or at play. So single elderly people, there's usually somebody at home, right? So we know there is a bias if you don't make multiple contact attempts to try and reduce the non-contact bias in a telephone survey. And then the classic example, an internet survey. So if somebody just sticks online a link, say, please do this survey, right? I'll give you $10 if you answer my questions. Then clearly that's a self-selected group. It's only people who are interested in that topic or are interested in the money you're offering will answer that survey. There's no indication that we can generalize the findings from that sample to the general population. That's clearly not a probability sample. So this next little bit about telephone surveys, if you're not interested in telephone surveys, you can skip over it. But I think it's generally quite useful to understand this, simply so that when you're reading a report of a survey in a newspaper, you understand the strengths and weaknesses. So if you have a choice of survey between telephone and face-to-face, which you're going to choose, right? So face-to-face in Hong Kong is very expensive in general, because you have to send researchers out to people's office or home or school. Telephone generally would be much cheaper. Telephone, though, has certain key weaknesses. Telephone loses visual contact. So, for example, we did a survey for the government on designs for the old airport. So where the old airport is in Kai Tak, there was, I think, 4 competing designs for redeveloping Kai Tak. So the government wanted to show people the designs and ask them which one they like. So you clearly can't do this over the phone, because it's impossible to adequately describe those designs in words over the phone. You need people to be able to watch that video, which means you either need face-to-face or maybe online, so at least they can watch the video first. But compared to face-to-face, it's much easier to supervise a telephone survey. The cost is much lower. The collection process is faster because you don't spend time traveling. It's much easier to have a computer sitting there with a nice big screen sitting on a desk than you have to carry around an iPad. So what about mobile versus fixed? So mobile versus fixed line penetration in Hong Kong is still about 70%, which is very high by world standards. But mobile penetration is close to 100%. So there's very few people now who do not have mobile phones. It is still a little low for the elderly, but increasingly their children have given them a mobile smartphone to look after, even if they just use it for WhatsApp. And fixed line coverage is quite low for young households, in the sense of newly formed households and the unemployed, because fixed lines are now more expensive than mobile. Telephone versus face-to-face. The other issue with face-to-face is you need to get access to people's home, which means you need to be able to get inside the building. So for many private housing estates, they're very reluctant to let interviewers in through the door. Schools can be much easier, but generally for schools you normally are forced to do self-report. It's very hard to get permission to go and do the surveys face-to-face in a school. It takes too much time out of the school day. Now, one issue for everyone is primary versus secondary data. So secondary data analysis means reusing data that's been previously collected. As I've said before, data collection is very expensive and usually not repeatable for social science data. So the use of previously collected data or materials is a good idea if you can get access to it. So there are data archives in the UK, US and Norway, for example, Taiwan. This is really critical when data is expensive or impossible to collect again. Now, what about sample size? We haven't really talked about sample size yet. So there are at least 3 things we need to think about: sampling error, non-sampling error, and power. So we will talk about power later on. So sampling error, we will see, is a relatively simple thing, because the sampling error depends on the sample size in a relatively simple way. Non-sampling error, as I mentioned, is much harder to assess, and so you need to know the literature well and understand the strengths and weaknesses of the methodology you're proposing and what you might be able to do to limit or restrict non-sampling error. Observation versus participation. So this is primarily about human beings, right? So the difference is Observation means I actually watch and see how you behave, as opposed to asking you to self-report how you behave. The problem is that people don't always tell the truth. They may not even realize they're not telling the truth when they're doing a self-report. But observation is generally very expensive to do. So historically, one of the things people used to do was to use the mail service. So this never worked very well in Hong Kong. The idea was you would drop an envelope on the street and see whether people would put that envelope in the post box. The idea was, if people do that, then they are there's a lot of social support, that they're willing to do the effort on behalf of others whom they don't know. And there was even two versions where you put a stamp on or you don't put a stamp on the envelope. Well, that doesn't work in Hong Kong, because in Hong Kong, if there's an envelope in the post box without a stamp, the post office still deliver it, but they just charge the person who receives the letter for the post. Okay, so it doesn't work. But at least it used to be a way of testing social behavior. Clearly it doesn't work anymore now, because so few people mail letters, right? So that's an example of the sorts of thing, trying to understand how people actually behave rather than how they say they're going to behave. Now, qualitative versus quantitative. So what is the difference between these two? So sometimes people used to distinguish it by the type of data collected, things which were directly measurable as opposed to recordable. So text or audio or video people would often see as qualitative data, because they were things you could record, but they were harder to quantify. But these days, we're becoming much more skilled at applying measurement, even to text or audio or video. Right, so it's less about the type of data we collect, it's more about how we collect it. So the qualitative form of analysis is much more concerned with the context and the counts, and is focused on a richness of understanding. So particularly if I have no pre-existing hypothesis, if I'm trying to start from scratch to understand some phenomena, this is generally where people are more interested in using qualitative research. On the other hand, because qualitative analysis does not generally use probability samples, then generalizability is much harder. So sometimes people use the combination of the two. They may use qualitative first to understand the issues, and then quantitative to measure the responses for those issues, or even in reverse. Quantitative first to measure their responses, and then if there's anything unusual, then qualitative to try and understand why people do the things they say they do. Okay? So that brings us to the end of chapter 3.